this is loading. Everything's so slow. So I don't know why this is so slow. Let's see here. What is going on? Oh, that is why, probably. So now, having technical issues, people, so give me a minute. Hi, Talia. Okay, maybe we can start now. Yay! Oh, yeah, I get too excited here. But maybe we can start. All right, let's see if this works now. If not, then we may call it. And then I have the video already up for you guys, but let's try to see if we can make this work.
Mr. Delgado, I have a question.
Yeah.
When will you be putting in the grades? Because like what is it called? The progress reports that come out today.
Yeah,
Like the quiz
progress
grades.
reports are coming out. Is it today? No, it's not today.
I think they're being printed today. I'm pretty sure.
Then it wouldn't be there already. Your progress report, whatever assignments they were. I think your 5.1 I did put on there already. If it's not showing on your end, because several people mentioned it wasn't showing on their end, just refresh your page or get out of whatever it was because it was showing some old data for some students. They kept on emailing me about their progress, but it wasn't showing. So check it again. I'll double check and I'll email you about it. All right. It seems to be kind of working now. So let's see now. So the time I didn't lose waiting for people, I lost trying to get this thing going. So this is, for those of you taking notes, 5.3, double angle power reducing and half angle formulas. So we started with double angle formulas last time, right? So our objectives, excuse me, are to learn how to use all of these, right? The double angle formula, the power reducing formula, and the half angle formulas. And they're very useful to you going forward. Those of you going on to calc, you're going to need them. So you got to learn them, memorize them. The more you practice, the better they are, the easier it is going to be. And we can prove all of these, but I will put, if you look at the links that I put on there for School Yourself, they kind of give you an informal proof. And I believe in your book, if you read through, they give you the proof to one of them. The other ones are left as exercises. But I will also probably post something on the proofs if you want to know how they came up with these formulas or where they come from. But the School Yourself gives you a pretty good idea. So this is your first example. The first, we're going to go with the double angle formulas, right? We did some of these, I think, last time. If you took some notes, go ahead. This is example 1. And it's going to be the same information for the next ones because we're going to find the sine of 2 theta, the cosine of 2 theta, and the tangent of 2 theta. So it says if sine of theta equals 4 over 5 and theta lies in quadrant 2, find the exact value of sine of 2 theta. So we're going to do sine of 2 theta first. If you recall, or if you read or looked at your notes, sine of 2 theta was what? Anybody?
2 sine theta, cosine theta?
There you go. 2 sine theta, cosine theta. Good, Anthony. Okay. 2 sine theta, cosine theta, right? So, and this one's going to be easy enough because they gave us already what sine of theta is, right? They told us sine of theta is 4 over 5. The question is, how do we find cosine of theta, right? So we're going to take it as if with the information that we have, we're going to take it right from the beginning. So what is the sine of theta? What does that mean? In terms of this, that means my angle theta, and they told me it's in quadrant 2, right? So that means theta is over here in quadrant 2. My angle is going to be in the second quadrant. And then I would draw my triangle for reference, right? And that's x, y, and r are my values, right? X, y, and r being the radius, right? If you think of the unit circle. So if you recall, sine of theta is what over what?
Y over R.
Y over r. Good, Dalia. Y over r. And we already have those values because they told us sine of theta was 4 over 5. So it is 4 over 5. That means that that's what goes in there, right? Y is 4 and r is 5. But what are we missing? We got y, we got r, so we need to find what?
X.
We need to find x, right? So in order for us to find cosine of x, we need to find x first. Good job, Talia. Okay? And what am I going to do to find x?
Pythagorean theorem.
Very good. Pythagorean theorem or Pythagorean theorem, whichever way you want to say it. So we put in our values. X squared plus y squared equals r squared, right? So we're trying to find x. From here, you substitute and you solve for x. You recall that from last class, right? So x is going to equal 3 or negative 3.
-3.
Why negative 3, Talia?
Because it's in the second quadrant.
Because it's in the second quadrant and cosine is negative in the second quadrant. Think of it this way. You're going in that direction towards the left. So therefore, it must be negative. So now we can figure out what the cosine of theta is, right? Cosine of theta in terms of x, y, and r would be what?
-3 over -3/5.
Very good. -3 over 5. It's x over r, which is -3 over 5. Good job, Talia. Okay? So it's -3 over 5. So then that's what I'm going to put in there. And the rest is multiplication, right? Multiplying fractions, dealing with positive and negative numbers in calc. And from this point forward, like I told you, all of it is new. None of it is hard, but there are a lot of places to make mistakes. You're going to see that there's a lot of little work involved. So you got to be very clear on multiplication, addition of fractions, all that kind of stuff. Dealing with fractions, positives and negatives has to be clear because there's a lot of places where you can make mistakes. In other words, you'll do all the work right, and then all of a sudden you, oh, but it was supposed to be negative. Where did I miss a negative? So that's what happens a lot. And the more practice you have, the less mistakes you'll make. So the answer is, anybody? There you go, -24 over 25. Good job, Christopher. Okay, -24 over 25. Everybody good with this? Let me see, make sure I can see everybody. Give me thumbs up, thumbs down, thumbs sideways. Use your little reaction buttons if you want, or you can just show me a picture. Thank you, Talia. Thank you, Martin. Everybody else is copying down. Bianca, Sierra, Zach. We go. Thank you, Sierra. All right, there we go. We'll move on. So people are either writing down or probably getting a snack. Snack, food. All right. So let's take, we did sine, now it's cosine. Notice it's the same information. Sine of theta equals 4 over 5, and theta lies in the second quadrant, and they want us to find the exact value of cosine of 2 theta, right? So this is why I tell you, knowing these formulas is important. And some of you are going to go, I don't know how to do this. I mean, I don't know how I remember this anymore. But then automatically you're going to be spitting stuff out related to trig, which is really cool, because all of a sudden you're going to know all this trig, and you don't know how you remember it. You're going to remember it just as easily as you remember how to add and subtract, because you've done so many problems, okay? Now this one's easy. If you remember the formula, you're done in 2 seconds, right? So let's see, who remembers cosine of 2 theta? Anybody? Nobody remembers?
Cosine cube, square
Square.
theta minus sine squared theta.
Very good. Cosine squared theta minus sine squared theta. Good job, W, right? And from here, it would be plugging in the values. Because we have them already, we can just plug them in and solve, right? Now, if we didn't have the values, then we would have to go through the same process, right? What's the process? Well, let's figure out what we have in terms of X, Y, and R. And then we would figure out what we have. And then we would use what to figure out? We would find that sign because they gave us sign, right? And then we would have to find X, right? And to find X, what did we do? What did we use? What do we use in order to find x? They gave us sine of theta, so we had y over r, right? Which was 4 over 5. All we were missing is x. If you have a right triangle, what can we always use? Anybody? There you go, Pythagorean theorem. Good job. Okay, Pythagorean theorem again, right? And then we would solve. Good job, Christopher. So we've got x equals -3, right? And we said it was negative because we're going to the left. We're in the second quadrant, right? So now we already had this information. So if you solved it already, great. That's what you should have done because we had that information, right? Now we get that the cosine of theta is x over r, so it's -3 over 5. And then the rest is just algebra. So somebody go ahead and finish working it out and tell me what the answer is. For those of you who are already done with this, we did sine, we did cosine. Guess what we're going to do next? Anybody got an answer for me on this? -1/5, I see. Christopher said -1/5. Anybody else got something else? Okay, we'll go with Christopher. So we got -3 over 5 squared. So that's going to be 9 over 25, right? And then for the second one, we've got 4 squared, which is 16, right? So it's -16 over 25. And 9 minus 16 is going to give me what? -7 over 25. So I don't know if yours was a typo, Chris, or if it was you added or subtracted something wrong. Oops, yeah, probably a typo. All right. Everybody good with this one? Yes, no, maybe so. I'm looking for thumbs up, thumbs down. Got a thumbs up there, thumbs up, thumbs up. Thumbs up, thumbs up. All right. Thumbs up everywhere. Love it. You know, you are going to have to show me your faces later. You know that how happy that makes me when I see you guys and I hear you guys. Makes me very happy. You know what, though? Got to cry throughout the whole entire video. It's so sad. All right, find tangent. Tangent of 2 theta. All right. Who can tell me what the formula for tangent of 2 theta is to help those others out that didn't read and didn't take notes? Anybody remember?
Tangent theta over 1 minus tangent theta.
Very good. Good job, Talia. Good looking out for your peeps. Tangent theta minus over 1 minus tangent squared theta. Okay. And here's where it seems like it's difficult, but things just work themselves out. Again, if we didn't know, then we'd have to figure out cosine, and we'd have to figure out tangent, right? So the same thing as before, right? If we knew tangent, we could just plug it into there and solve, right? So the question is, how do we find tangent? How do we find tangent, right? Well, we already had sine and cosine, right? We did this stuff, and I'm not going to have you write it again, or you can just look along, right? Remember what we did first. Find out what y and r are, and then we have to figure out x. What did we do to figure out x? We used what? Euler. Am I dating myself? Nobody's seen Ferris Bueller's Day Off? Gotta see that great movie. So then we did what? Pythagorean theorem. And then we solved. We got that x was -3 because we're going in that direction. And then we figured out the cosine, right? So now we have sine and cosine. So how do we figure out tangent? We have sine and cosine. What's tangent in terms of sine and cosine?
Sine over cosine.
Sine over cosine. Very good. It's sine over cosine. So if I put sine over cosine, right, what's going to happen? If I put sine over cosine,
The 5s are going to cancel out.
odds are going to cancel out. Very good. 5s are going to cancel out. So my 5s will cancel out, and I end up with a negative 4 over 3. So now that's what goes in my question marks, right? In my parentheses, it's a negative 4 over 3. And now you see you have a complex fraction within another complex fraction and negatives everywhere. This is why I tell you it's kind of, you've got to be careful with positives, negatives, and you've got to understand your fractions pretty well, okay? Because you're going to see this all the time next year in calc, okay? So this has to become automatic. Once you get to here, you have to trust yourself and say, that's it. I've got the answer. I'm going to be right. But there's still work to do. That's just the bottom line. And a lot of this goes on in your head, right? So in the top, you've got 2 is 2 over 1, so you've got a negative 8 over 3. Notice that's the same step from before, right? Same place. And then on the bottom, you've got that squared, so it's going to be 1. Is it going to be a plus or a minus? Anyone? Is it going to be a plus or a minus?
It's going to be a minus.
It's going to be a minus, right? Because that negative is inside the parentheses and it's getting squared, right? And it's getting squared. So therefore, it's going to be a minus, right? And it's minus 16 over 9. I just saw your comments, Christopher. I'm a little behind, sorry. So it's going to be negative 8 over 3 over what? That 1 is going to be what? I need a common denominator, so it's going to be 9 over 9, right? And then I subtract those, and I get 9 minus 16.
7 over 9. Negative 7 over 9.
Very good. Negative 7 over 9. 9 minus 16 is 7, so it's a negative 7 over 9. Good, Anthony. Okay? So now, notice, we were really done a while ago, but there's a lot of work, little work to be done, right? This is why I say your stuff has to be cleared. We're dividing fractions, right? Complex fractions. Dividing is the same as multiplying by what?
It's reciprocal.
It's reciprocal. Very good, Talia. I have to multiply by the reciprocal, so it's going to be negative 8 over 3 times negative 9 over 7. And here it's just a matter, if you want to simplify first or multiply them first and then simplify, it's up to you. I usually simplify first, so that 3 goes into 9 3 times, and I would get 24 over 7. Okay? Good, just no, maybe so. Again, for those of you who are here, if you need to leave for whatever reason, make a comment on the chat so I know that you were here, because remember, I take the picture for attendance at the end. So if you need to leave for whatever reason, just say goodbye, Mr. Delgado, or I got to go, Mr. Delgado, or you're the best teacher ever, Mr. Delgado. I'll take any one of those. All right, so there are 3 forms for the double angle formula for cosine of 2 theta. One was the one that we used, right? That's the one that Talia said for us earlier, right? Cosine of 2 theta is equal to cosine squared theta minus sine squared theta, right? That was one of them. And there's 2 other forms, right? And it's important to know these because depending on what you're doing, you might have to use one of the other ones. The next one is cosine of 2 theta is equal to 2 cosine squared theta minus 1. And the last one is cosine of 2 theta equals 1 minus 2 sine squared theta, okay? So the question is, when do I use which one? It all depends on what you're trying to do. And you're going to see that in the next example, okay? We have 3 different forms, so we got to see which one is going to be beneficial to us. Everybody got these formulas down? Just no, maybe so. Good. I don't see thumbs. There we go. Thumbs. Thumbs. Okay. We good. We move on. It says verify the identity. So go ahead and copy the problem. It says verify the identity. Sine of 3 theta is equal to 3 sine theta minus 4 sine cubed of theta. Okay. So now remember, when we're verifying identities, we always work with what? The easiest one or the hardest one? The hardest side. Do you start with the easy side or the hard side?
Hard
The
side.
hard side.
Hard side. Very good, Christopher and Taliana. You start with the hard side, right? And in this one, which one looks like the hard side? The left or the right?
The right.
The right. It looks like the hard one, right? It looks like the hard one, but I thought the same thing too until I stopped and I thought about it. The hardest thing in this problem is the beginning, the first step. After the first step, it's pretty easy. Give me 1 second. Yes.
When are you done?
In an hour.
What time?
12. About 1:30. Okay, bye. My daughter wanted to know when I was done. All right. So, why does the right look more difficult? Because it's got two terms, it's got a cube in it, but there's something very strange to me about the left side, right? Because at first I looked at it and I said, that looks more difficult. And that's the way I tried to work it out at first. I tried with the right hand first and it just started getting weird. And then I figured out what? The left looks so easy that I didn't realize it says 3 theta. Do we know anything about 3 theta? We've talked about sine of theta. We've talked about sine of 2 theta, but have we ever talked about something related to 3 theta? Yes, no, maybe so. Can't be wrong on this one. Well, you can't. So sine of 3 theta is something we haven't dealt with, right? So this is the first step is the hardest one in this one. The first step is the tough one. After that, it's actually not too bad. So what is the first step here? Well, you have sine of 3 theta. I have no idea what to do with that, right? But I do know stuff about what? Sine of sine of 2 theta, right? I do know some stuff about sine of 2 theta. So I can always rewrite 3 theta as 2 theta plus theta, right? So that's exactly what we're going to do. We're going to rewrite 3 theta as sine of 2 theta plus theta. So that's step 1. And that's the hard step. After here, it gets pretty easy, but you have to recall a lot of stuff, okay? So now, do you remember when you had sine of A alpha plus beta or A plus B? Remember that? Well, that's the same thing here, right? Now we have sine of 2 theta plus theta. So we have sine of alpha plus beta. What was sine of alpha plus beta? Who remembers that?
It's sine of alpha times sine of cosine of beta, and then plus cosine of alpha sine of beta.
There you go. Good job. Good job, W. So that's what it is, right? So now in here is I can apply that to this, sine of 2 theta plus theta, right? So it's going to be what? What's my alpha? My alpha is 2 theta, and my beta is theta. So God, what language are you speaking? It's math, people. So it's going to be what? Sine of 2 theta, that's my alpha, and then cosine of theta, which is my beta, and then plus cosine of 2 alpha times sine of theta. Looking a little better, sort of, because I know something about sine of 2 theta, don't I? I've got to deal with this, right? Sine of 2 theta. So what is sine of 2 theta? Sine of 2 theta is what?
2 sine theta cosine theta.
2 sine theta cosine theta. Good job. Okay. And I know something about this one over here, cosine of 2 theta. What's that one?
cosine squared theta minus sine squared theta.
Very good, right? That would be one, right? Cosine squared theta minus sine squared theta is the one that we knew, right? But the question is, remember we just wrote down 3 of them? The question is, which is the best one to use here, right? Which one of those 3 is the right one to use in here, right? So Talia wasn't, this is the one that we used in the other problem, but now we have 3 of them. So which of these 3 would be the best one? Always go back to the problem and look at what you're trying to verify, right? We're trying to verify this identity. And what do you notice that we're trying to get to? The other side only has what? What trig function?
It only has signs, so we should use the third one.
Very good, Christopher. It only has sine, so we should use the third one, right? Because that one puts it equal to sines. Got the idea? Good job, Christopher. Okay? So we're going to use this, the third one. We're going to replace it with 1 minus 2 sine theta. So the rest stays the same, but we're going to replace, for sine of 2 theta, we're going to replace it with 2 sine theta cosine theta. And cosine of 2 theta, we're going to replace it with 1 minus 2 sine squared theta. We're getting there, almost there. And now we just have to multiply, right? Multiply what we can multiply together. So let's see. We have 2 sine theta. What's cosine theta times cosine theta?
Cosine squared theta.
Good job, Christopher. Cosine squared theta. And then it's going to be plus. Now I need to distribute here, right? I've got sine theta times 1 is going to be sine theta. I'll help you out with that one. And then the next one, what? Sine theta times 2 sine squared theta is going to give me what?
Two sine cube of theta.
Good, Dalia. 2 sine cube of theta, right? So it's minus 2 sine cube of theta, right? We're getting there. We're getting close. All that we have left is what? We have to deal with this guy over here, right? That cosine squared theta, right? Well, I remember that one of the Pythagorean identities says that what? Sine squared theta plus cosine squared theta is equal to
1.
1. Good job, Christopher. Okay? So that means if I subtract sine squared theta from both sides, I'm going to end up with the cosine squared theta equal to what?
One minus sine squared. Sine squared theta.
There you go. 1 minus sine squared theta. Good job, Christopher. So I'm going to replace that cosine squared for 1 minus sine squared theta. Now I've got everything in terms of sines, right? And from here, it's just a matter of distributing and combining like terms. And I should end up with the right side. So let's see what that looks like. Everybody good with this one? So this is the same step as before, right? So now I'm going to distribute here. So 2 sine theta times 1 gives me 2 sine theta, and then 2 sine theta times a negative sine squared theta is going to give me anybody?
Minus 2 sine cubed theta.
Very good. Minus 2 sine cubed theta, right? And then I have plus sine theta, just bring the rest down, right? Minus sine cubed theta. And now I have to combine my like terms, right? So these are my like terms. I've got 2 sine theta plus another sine theta is going to give me three sine theta, right? And then these two, minus 2 sine cubed theta minus 2 sine cubed theta is going to give me
Minus 4 cubed theta.
very good, minus 4 sine cubed theta. Give you a minute to write that down, and then we'll move on. You got the idea? It's not too difficult, right? The first step was the toughest one. And it just seemed simple, but that was a tough step. The rest is just applying what you've already learned. So that sine of alpha plus beta, sine of alpha minus beta, cosine of alpha plus beta, all of that is going to come around. Okay? All of that is going to come back around. Okay, show me thumbs up if we're good, so we can move on. Good, Martin. Good, Christopher. Good, Anthony. Bianca's sleeping. Zachary's having a snack. Nico's listening to music. All right, we're good? Let's move on. Next, power reducing formulas. These are really useful. The idea of power reducing formulas is that you take your powers for your trig functions and you can reduce them. You can bring them down the power. So that's why they're useful. Okay, that's what they help us do. So sine square of theta is equal to, anybody have it in their notes? Yes, no, maybe so. I'm going to go with no. So it's 1 minus 2 cosine theta over 2. Cosine square theta is 1 plus cosine of 2 theta over, somebody guess. There you go. Good job. Over 2. And then you guys can do this one in your head, right? Tangent square theta. What's that one going to be?
1 minus cosine of 2 theta over 1 plus cosine of 2 theta.
There you go, right? Because the 2's cancel out. Remember, tangent is sine over cosine, right? So those 2's in the denominators are going to cancel each other out. Write those down. We good, just no? All right, moving on. So it says, write an equivalent expression for a sine to the 4th power that does not contain powers of trigonometric functions greater than 1. So we've got a sine to the 4th power. We want to rewrite that expression with something that has no exponents greater than 1. That's a lot of reducing to go from 4 to 1. So how do we do that? Well, I remember way back when, I'll tell you a story, way back when, a lot of the stuff that goes into thinking will be in red on the right side of your presentation over there, okay? I remember that if I had a power to a power, it was called a power to a power rule or something like that, you learned it. So if you had a to the m to the n power, right? Then it was a to the m times n. So that means that works backwards also. That should work backwards also. So if I have a thing that's multiplied together, I can split up the powers. Everybody see that? So the question is, what can I split that to if it's a 4?
2 and 2.
2 and 2, very good, Anthony. I can split it up to 2 and 2. So that would be a 2 and 2. And now that I have a 2 and 2, I do know something about sine squared of x, right? I just learned something about sine squared of x, right? Because remember, I'm trying to bring down the power. So what am I going to use? I'm going to use I could do that, right? Because I know that's true, right? But is that going to help me bring down the power? Remember, the idea was what? That I should have no powers greater than 1, right? So is that going to help me if I use that for sine squared of x? I know it's 1 minus cosine squared of x, but that's not very helpful, is it? So what can I use? So the question is, what can I use? I'll give you a hint. You got it now? So I got to use my power reducing formulas, right? Sine square of theta, which we said was what?
1 minus cosine 2 theta all over 2.
There you go. So 1 minus 2 cosine theta all over 2. Good job, Anthony. Okay. So now I'm going to substitute that in there, right? I'm going to substitute that in there. Did I write that wrong? Did I write that expression wrong here?
The red one, you wrote it wrong.
The red one, I wrote it wrong. I wrote it right in the other one, right? So yeah, so this is the cosine of 2 theta. Thank you, Anthony. Let me see if I can fix that. If it'll let me. I don't know. This should say cosine 2 theta. Oh, that's lovely. So, Gala, you can't write. All right, cosine, assume that says cosine of 2 theta. It's right in the black, it's wrong in the red. All right, moving on. So now, what's next? Well, what can I do with that? I remember when I had a over b to the second power, that's the same as what? A to the second over b to the second, right? So the denominator is not going to be a problem. The denominator is going to be a what? What's 2 to the second? Bueller. Right? So that's my denominator. It's a 4. So now the question is, what do I do with the numerator? And I remember this, right? Notice how much math you have to recall, right? That was what? Anybody remember that? A minus b quantity squared is the same as a squared minus 2ab. And that shouldn't say minus, it should say what?
Plus.
Plus. Very good. That should be a plus b squared. Hey, I was able to write. Lovely. So now my a is a 1 and my b is cosine of 2x. So it's going to be 1 minus 2 times cosine of 2x plus cosine squared of 2x, because this might be squared, right? Cosine squared of 2x. And now what do I do? Okay, so that's my numerator. So the question is, what do I do now? I still have a power of 2 there, right? So I can split these apart, right? I can split these fractions apart. If you recall, a plus b plus c, I can split those fractions apart. So I'm going to end up with 1 over 4 minus, what's 2 over 4? When I reduce it, I get what? One half, right? Cosine of 2x, that's my middle term. And then it's going to be what? Plus, even though we don't see it, there's a 1 in front of that cosine squared of 2x. So it should be plus 1/4 cosine squared of 2x. Got it? Just no, maybe so? And now what?
We have to get rid of the squared in front of the cosine.
Exactly. I got to deal with that. Good job, Christopher. I got to deal with that cosine squared of 2x, right? So how do I deal with that? Well, I remember cosine squared of theta was what? 1
1 plus cosine 2 theta over 2.
1 plus cosine 2 theta over 2. Very good, right? So I'm going to do what? Take that and substitute it in here, right? Now remember, when I substitute it in here, my theta happens to be a 2x, right? So that's why my theta is a 2x. So I'm going to have cosine of 2 times theta, but my theta happens to be a 2x. Everybody good with that? So let's see what we do now from here. At this point, every power is less than 1 or less, right? No power is greater than 1. All my powers are 1, so I just need to clean this up. So the question is, how do I clean this up, right? Order of operations, parentheses first, right? In the parentheses, I have that 2 times 2, and then I have that 1/4 times the 2 on the bottom, so that's going to give me that 1/8. Got that? And then I have what? That 1/8 I need to distribute to both terms. So that's going to give me 1/4 minus 1/2 cosine of 2x plus 1/8. And then once I distribute to the other side, it's going to be 1/8 cosine of 4x. And the last thing is to combine my 1/4 and my 1/8, which is going to give me 3/8. So I have 3/8 minus 1/2 cosine of 2x plus 1/8 cosine of 4x. Notice your answers are not pretty anymore, okay? They don't have to be. Some mathematicians like to be funny, and they'll put these big problems, and then your answer is either 0 or 1. But in general, don't assume that your answers are going to be pretty and worked out anymore. Sometimes they are just like that. I don't know that they are ugly, but they're not what you're used to sometimes. Everybody good with this one? Yes, no, maybe so? Let me see here. Thumbs up, thumbs down, thumb sideways. All right, we're good here. Sierra, Zach. All right, good, good, good. Like I said, none of this is hard. It's just new, and you've got to learn how to work with the trig part. But it should feel very much like algebra. Like you're just doing algebra, except somebody's messing with you about the algebra that you're working with now. I didn't have my... No problem, Nicholas. You can go ahead and leave. Thank you for writing something down. All right. So let's see here. Half angle formulas. These are sine of alpha over 2 is equal to plus or minus the square root of 1 minus cosine of alpha over 2. And then the cosine of alpha over 2 is 1 plus cosine of alpha over 2. And can you guess at what the last one is? What happens to the square roots on the bottom, the square root of 2 on the bottom? What are they going to do?
Cancel out.
They're going to cancel out, right? So it's going to be, the last one is going to be plus or minus the square root of what, Talia? What over what?
1 minus cosine of alpha over 1 plus cosine of alpha.
Very good. Okay, good job. So it's going to cancel each other out. All right, Zachary, I'll see you later. So let's see how these apply. Remember, you have a plus or minus here, right? That plus or minus doesn't mean that you have two answers. You're only going to have one, and it depends on where the angle alpha over 2 is going to lie, right? So it says the symbol, plus or minus symbol in each of the formula does not mean that there are two possible values for each function. Instead, the plus or minus indicates that you must determine the sign of the trigonometric function plus or minus based on the quadrant which the half angle a over 2 lies. Okay? So that means wherever the angle lies, that's going to be your plus or minus. Bye-bye, Sierra. Have a good day. So use the cosine of 210. This is your problem. So this is your last example, and then I'll give you the formulas for tangents. Use cosine of 210 equals negative square root of 3 over 2 to find the exact value of cosine of 105. Okay, so how do we do that? Let's see. Let's start off with what we know. We know that cosine of 105 is what part of 102? It is cosine of 210 over 2, right? Does that make sense? 105 is half of 210. So that means we can use that half angle formula, right? Cosine of alpha over 2 is equal to plus or minus the square root of 1 plus cosine of alpha over 2. That's the formula. So we're going to replace alpha with what value? What do we replace alpha with in the formula?
210.
210, right? 210. So it would be 210 over 2 is equal to, so should it be a plus or a minus?
Alice?
You think it's a plus, Talia,
No.
or minus?
I think it's a minus.
It's a negative, no?
It's a negative. It's a negative. Why is it a negative? Okay.
Because it's in the third
Well,
quadrant.
210 lies in the third quadrant, but we're not worried about alpha. We want alpha over 2, right? We want alpha over 2. Alpha over 2 is equal to what? How many degrees? Alpha over 2 is
105.
1 over 105. Very good. Alpha over 2 is 105. So that's what's going to determine it. Not alpha, but alpha over 2. Does that make sense, Talia?
Yeah.
Yeah. So that's going to be a negative, right? Think of it that way, right? Remember, 105 is in the third quadrant. So it's going to be negative, and then we have 1 plus cosine of what value? That should be alpha, which is
210.
210, right? And then now we just substitute the values. We already knew that value because they told us right from the beginning, right? So that should be 1 plus
Negative square root of 3 over 2.
very good, negative square root of 3 over 2. And then from here, we just have to clean that up. Notice they're starting to get ugly. This is what I mean when things kind of get ugly and you have to clean them up. Because you have fractions, you got square roots, you got negatives under radicals. It gets a little tricky, but you just one step at a time, right? Trust what you know. Everything you learned from 4th grade or 3rd grade on applies even now. So from here, they did it a weird way. I did it totally different. And then I looked at what they had and they did it different. So I added an extra step so you guys can see what happens from here. That's the step that they're at, right? What they did was they went ahead and they multiplied times 1. Because remember, in math, we can multiply by 1 just because we feel like it, right? So they went and multiplied by 1 under the radical. I would have probably taken a few more steps, but that's just the way I learned it. I would have probably split them up and then cleaned it up. But they did it like this, right? Everybody got that? Does that make sense? If you're multiplying by 1, you're not affecting it in any way, right? But they used a different form of 1. Instead of 1, they did what? 2 over 2, so then they could rationalize the denominator, right? And that 2 in the numerator looks like it's part of that denominator of the other fraction, so it's actually part of the numerator, right? So I just put it a little bit more up so you can see that those two 2's are going to do what? What are those 2's going to do?
Cancel out.
Cancel out. They're going to cancel out, good, Christopher. So they're going to cancel out. So what do I end up with, right? I would end up with this. The square root of 2 minus the square root of 3 over 4. And it's negative square root of 2 minus the square root of 3 over 4. And the square root of 4 is what?
2.
2. So I can just take the square root out from the denominator and just keep it in the numerator. Look at that. That looks so much better than we had before, but it doesn't look probably one of the first times you've ever seen a square root of a square root, right? Have you guys seen that in a problem before? Did you see it in Algebra 2?
No.
No, right? So you're going to start to see more of that, okay, as you go forward in math. You're going to see some really cool looking stuff. All right, we're good with this one? Yes, no, maybe so? My 3 math faithful that are left? All right, so for the last one, we're not going to do a problem. Good job, Talia. Go ahead and copy these in case you don't have them, and we're going to end it here. Okay, copy these, and they work the same way. Okay, it's just a matter of practice. If you run into issues, as always, take a picture, send them to me, and I'll try to either give you a hint, or if you want me to solve it, I'll solve it, and I'll send it back to you. Okay? Everybody good with that one? Just know maybe so. I take picture of my math faithful. Show me your faces, my math faithful. So I can take a picture of my math faithful. You look fantabulous, all of you. Yeah. Give me a thumbs up there. All right, here we go. Got everybody. Thank you, guys. So any other questions? As usual, let me know. I will post this as soon as it renders. I will post it on the site in case you want to take a look back at something that you didn't quite get so you can see it again. Okay? Have a wonderful afternoon. See you all later. Bye. Thank you. I see you all later. Bye. Hey, Martin, how are you? Hi, Bianca.